Hi, my name is Vlad, and I will talk about my progress in bringing quic to the D environment. The first question is, what is quic? It is a network protocol that seeks to replace the TCP. The official RFC was published in 2021. Right now, it is used by about 7% of the old websites, and it's supported by the most popular web browsers. The question is, why would someone consider switching from a protocol like TCP to quic? The most important aspect is the fact that quic is implemented in the user space. Other protocols like TCP are implemented in the kernel space as a driver. One advantage of this different structure is the fact that it's simpler to update. If you want to change something to that protocol, you have to do that change only at the ends, the communicating peers. We don't have to care about the middle boxes. We do not have to care about operating system life cycles. And for those middle boxes, the devices along the path, that quick transmission is just a simple UDP communication. And because everything is encrypted, including the header, they cannot tamper with that communication. And another advantage is, of course, you can leverage the use of D, features like fibers and exceptions. Another advantage over TCP, it's the fact that we can multiplex our streams. In the traditional architecture like TCP and HTTP2, the multiplexing was implemented in HTTP2. Now every application can benefit from this feature. While I was working on this project, I read about a design pattern for network protocols called IO-free design pattern. What does it mean? It means that for me as a developer, I don't have to care about how the data comes to me. I give the user the options to choose a concurrency model, to choose what kind of sockets does he want to use. And what the advantage of using such a method is it's simpler. We can reuse this library. Every user has the choice to use what kind of concurrency model he wants. It is easier to test. We can create basically a quick communication offline, and we can interact with this through unit tests, and it is more modular, it's decoupled from the real network. This kind of pattern requires you to implement four main functions. The connect function, that function provides the initial key generation, it generates the handshakes that you will have to send on the network and so on. Another one is to parse the incoming datagrams. What does this do? By parsing them, we can discover what the other peer communicates to us. We can end the handshake. We can add data to our streams. And we can send notifications. The provide datagrams function is basically the opposite. If you have any data on the streams, quic will send it on the network. And of course, we want to close the connection. One problem that I encountered while working on this project was the framing. Another difference between TCP and quic is that the fact that the cryptography data, it's embedded into quic packets. In TCP, the initial handshake was something separate from the actual TCP transmission. And now, the current structure is like this. We have an UDP datagram at the top. This datagram can have one or more quick packets. In each packet, we can have one or more quick frames. In some quick frames, we can have one or more TLS frames. And in each TLS frame, we can have one or more TLS extensions. So it kind of gets complicated. And the other problem is that each kind of frame has different rules of encoding and decoding. Some require you to put the length at the beginning. Some require you to put the ID at the beginning and the length later. And each frame has a different way of encoding that length. Some require a fixed number of bytes to encode the length. Some other require a new data type, a var int, that to encode that, especially in quick frames, to encode that the length of the incoming frame. Here we have some code, and with some attributes, I managed to work with some user-defined attributes that let me tag each field according to the rules provided by the RFC. We have fields where the length is provided with 2 bytes, with 1 byte, with other that have that variant length, and so on. And also I had to add such an attribute to the frame itself to know if the length of the frame itself should be first, the ID, and so on. The problem is that each kind of, especially the difference between quick and TLS frames, have different rules. When I want another part of the library to read such a struct after I got it on the network, I used an op-dispatch operator that basically, at compile time, goes over my fields and generates the required code as guided by my attributes. I have done a similar thing with the writing part. It's basically the mirror of reading. It iterates over each field in my struct. When I want to, I populate my struct with data, and with that get bytes function, I can convert my structs into plain bytes. Other things that I should mention is the quic-d module, in which I used the OpenSSL bindings. One task that I should do is create some interfaces, because now this cryptography module, it's hard linked to OpenSSL. We cannot use another library if you want. In this module, I implemented the header protection that allows us that protects us from middle box tampering. The middle boxes cannot discover what we are trying to transmit. If it's a handshake, we have streams and so on. I can generate the key according to the new TLS 1.3 standard. I can verify my certificates because this new standard allows you to have both ephemeral keys that change at every step, and you can also have to sign this communications using your permanent key, and you have to, in this way, you certify. I also worked a bit on a quick-stream module. As I've said earlier, Quick is able to and should guarantee in-order data communication, multiplexing. Now I managed to do a bidirectional stream. One connection, one peer that sends those data can signals that it ended its connection and this transmission, and he can change the direction towards receiving. On this part, I have to do more testing. It is not yet properly tested. Well, that was my talk. If you have any questions, I would like to hear them.
Question. So when you implement a protocol like this, is there like some test suites that you can use to check conformance? Because I guess there are lots of people writing the same thing in different languages. Is there some standard test suite that you can run your programming, your library against to see that it conforms with a quic protocol, or do you have to write that from scratch?
The thing is that the standard provides yourself with things that are compulsory to implement and other things that are not compulsory to implement. What it enforces you is the way to communicate with the other peer. The performance is up to you and up to each implementation.
Okay, but as part of the RFC, there isn't like some binary that you get that you can sort of test against?
Yes, indeed. There are examples that you can use to test, for example, the crypto module. And I used such test in unit test in my library.
Thank you.
What is the state of current implementations in the browsers, especially with regards to performance compared to TCP? Is this a great thing?
It is better than TCP, but there's another protocol, TCP-LS, which basically does the same thing. It moves the protocol logic out into a user space and also improves the cryptography part. And indeed, because TCP is a more mature protocol, it managed to beat quic.
Only in the new one you just mentioned?
Yes,
or, okay.
TCP-LS.
Yeah.
Hello, thanks for the talk. This might be way off, but I'm just curious. You're talking about cryptography. How resistant is this protocol to quantum? Is it post-quantum safe?
No, it isn't. It isn't yet. It should use, as far as I have read, you should use some lattice-based algorithms, which are not yet enforced by the standard.
So what do I have to do to use this in Vibe right now? Like in vibe.d, if I want to use it there?
Yeah, you can use it because it does not depend on and this was a requirement of the project. It should be a standalone library.
Okay, so like what things do I then have to technically do right now to say my Vibe project now also should support this protocol because TCP is way too slow and I want to have it faster?
It is not yet fully, it is in progress. But after I will hopefully get to a more mature implementation, you should use, for example, the stream part. You can initialize a session and you can send your, using that stream functions, you can be replaced basically. For someone like a vibe.d developer, there's no difference between using TCP and quic.
I have a question about the advantages of the quic protocol in the context of a person who's already using HTTP2, because there's a lot of similarity in concepts of like frames that can be interleaved in multiple parallel streams that are kind of multiplexed together. What are the primary advantages to a person who is already using HTTP2 of using quic versus TCP?
The advantage would be for a person that does not want to use HTTP2, and a person that would want to build its own application. Quic does guarantee you stream multiplexing and in-order data transmission.
Oh, it looks like we're good here. Okay, well, thank you for your talk.
Thank you.